All right, try that one. I'll rewrite it here. So first you got to do the powers outside parentheses thing, right? Powers outside parentheses, multiply powers inside. Powers outside parentheses, multiply powers inside. So invisible 1 power, so that 4 goes boom, boom, boom. Like that, right? So that 4 power outside will multiply all the powers inside. So we get 4 to the 4th, x to the 12th, y to the 24th. The bottom hasn't changed yet. Good so far. Right? And the parentheses are gone, right? When something from the outside goes in, drop the parentheses, drop the floodgates, the water went in. So that good so far. Powers outside parentheses, multiply powers inside. Now what? Well, same bases. Well, x to the 12 over x to 1. What are we going to do with these numbers? The numbers, you can just work them out. You guys have your calculator? What is 4 to the 4th? 256? 256, and this is just 4. So 256 divided by 4? 64. And it's going to end up what? Top or bottom? Top, because the bigger one's on the top. Everybody good with what I just did with the numbers, right? Just take your calculator. You can just go 4 times 4 times 4 times 4, or 4 to the 4th power if you have the power button. Get 256 divided by 4, 64. And it's in the top, not the bottom, because the bigger one was on the top. Subtract the 12 and the 1, x to the 11, subtract the 24 and 6, 18. There we go.
Is there a situation where you could not just subtract the invisible 1 power from the 4 from the 4 to the 4th?
Oh, yeah, no, that's good. You could do that too. Yeah, no.
Is there a situation where that would not be possible?
No, I can't think of any. That looks good. Yeah, so you can just go look. It's 4 to the 4th over 4 to the 1. That's 4 to the 3rd. And that comes out to be 64. Yep, that works too. Good. Does that make sense on that? Yeah, we did that. So normally I just work out the numbers. Just work out the numbers and then divide them, then subtract the powers. So divide the numbers in the front, subtract the powers. All right, so we have 16x plus 12 over 4. Yeah, so now we have a plus sign, and we're going to do minus as well. Plus and minuses in the top. When we have that, that's two separate terms. So what we're going to do with this is we're going to have to divide into each of them separately. So in other words, I would suggest that you just make it two separate fractions like that. That 1/4 will divide both of them. That makes sense so far? So do you see that the plus sign, what's different? Now this is where it gets a little tricky. What's different from this problem compared to all the rest of the ones we're doing is we have a plus or minus sign all of a sudden in the top. So whenever you have a plus or minus sign, that's a separator. That means those are two separate, different things. So this the 16x is separate from the 12. Is that good? So they're separate. So we separate them, and then we just do the normal thing. Divide them, 4x, divide them, 3. There we go. And that's all. Questions on that? Is that making sense? So what do we got? 24. So I'm just going to separate them, right? So go ahead and. So make it two separate fractions, right? So pluses and minuses separate things. Okay, now 24b squared. So we separate it like that into two different fractions. Good so far. Separated into two different fractions. And then we just divide the numbers in the front, subtract the powers. So 24 over 4, 6, subtract the powers, 2 minus 1, just b to the 1 or regular b.
What about the power?
So the 2 powers subtracted the 1 power to be 1.
Oh, done.
On that. And then the next one, 16 divided by 4 is 4. Now what happens with the b to the 1 over b to the 1? Well, subtract the powers, it's 0. And what is b to the 0? What's anything to the 0 power? 1. So this just vanished. It's just 4 times 1, which does nothing. Did you understand that scribbling out there, why I did that? Because it's b to the 0 power. Anything to the 0 power, remember, is 1. And 4 times 1, that's just 4. Or you could have just canceled them. Same effect. So that's our answer. Good on that. Separating those. Okay, so on this one, 10m to the third plus 25m over 5m squared. All right, so same thing. Separate those. Separate those. Divide the numbers in the front. Subtract the powers. So how are you going to remember on the test that these need to be separated? Pluses and minuses. Yeah, pluses and minuses is what tells us that. So good so far. So first off, I separate them, right? They each get that denominator, right? Because that's the denominator for both of them. Good to there. So far. Now, where do we go from here? 5 goes into 10 2 times. Divide the numbers in the front. Subtract the powers. 3 minus 2, m to the 1, or just m. Good so far. Plus, divide the numbers. 25 divided by 5 is 5. Subtract the powers. Now, what's the power on the m on the top? 1. Remember, invisible 1. Invisible 1. When you subtract, where's the bigger m? So the answer is going to end up m to the 1 on the bottom. And that's our answer. Does that make sense? Because the bigger one is on the bottom.
Or just
What's that? Or just m, yeah, m to the 1's just m. Just m on the bottom is fine. Yeah, that's right. Yeah, both those 1s I'm putting aren't necessary, right? These 1s you can just leave off. They're understood to be invisibly there. Does that make sense what happened there? So remember, wherever the bigger is, that's where the answer ends up, huh? So the trick was the bigger m was on the bottom for the second fraction. Bigger m was on the bottom, so that's where the answer ended up. Is that good?
Could you walk us through a similar question like this, if the next one's not?
We'll see. Yeah, let's see. Let's see how it is. Other questions on that one? Get back to something like that. Whoops, I just hit that. Try that one. So let me write it out. So 45 x to the third plus 54x minus 9. So all over 9. So you know what to do, right? Make it 3 separate fractions. Make it 3 separate fractions. Yep. How y'all doing? You making it through here?
For the most part.
Is too much math? Is math overload?
Overdose.
Some overdosing on math here. Didn't learn this stuff in high school.
Or elementary, wherever.
Yeah, high school I would
I
say.
didn't learn it in high school either, because all we had, because I graduated in '97, all we had was like math A and B, unless you wanted to go to like university or something, then you would take like algebra 1 and 2, so I've never even seen algebra until now.
Okay.
Yeah.
Yeah.
And they're really advanced now though, because like my daughter, she's like AP trig, and it's, I'm like, what the heck is that?
That's great. All right. Yeah, they're pushing algebra earlier now, aren't they?
And AP classes, I guess, too.
Yeah. Getting them ready for college. That's a good thing. All right. So 3 separate fractions. 3 separate fractions like that, right? So what's going to tell us to how are you going to recognize this on the exam next Wednesday to make them separate fractions? Pluses and minuses. Those are separators, right? Pluses and minuses separate things. Okay. So 3 separate fractions. Now, for each of those, divide the numbers in the front. So 45 divided by 9 is 5. 54 divided by 9 is 6. And 9 divided by 9 is 1. And we're done. Make sense?
You have to put the -1.
Oh, yeah.
9 over 9 is 1.
Right. Yeah. Right. Oh, I see. You might think, well, they cancel.
Yeah.
Well, they cancel and become 1. Really is what they do. Now, I know what's confusing. Well, so is like if you have like 9x to the 5th over 9x to the 2nd, you would just cancel and say x to the 3rd. Right? It probably was confusing. Like, why, I don't write them there. Why do you write them here? Well, it really did become 1 here also. But what is 1x to the 3rd? It's just x to the 3rd. So really, now, so this one you need to show because it's a subtracted one. Right? Multiplied ones, multiplying by 1 doesn't do anything. So we don't show multiplied ones. But we do show added and subtracted ones.
Because it's by itself.
Because that makes a difference, right? Think about 7 times 1 and 7 plus 1. Does this one matter? Does he change the answer? No. Does this one matter? Does he change the answer? Yeah. So added and subtracted ones matter. They change the answer. So they need to be there. So 9 over 9 or anything over itself is always 1. It's just a matter of whether we care, whether it's important to show it. So for multiplied ones, it doesn't matter. Added, subtracted ones, it does. Because they make a difference, don't they? Multiplying by 1 does nothing. Adding 1 or subtracting 1 changes numbers. So 48x to the 9th minus 24x to the 4th plus 30x all over 6x. So try to break that one into 3 fractions, right? Three separate fractions. Like that. Okay, then divide the numbers, subtract the powers. So 6 goes into 48, 8 times. Subtract the powers, 9 minus 1 is 8. Good so far. Divide the numbers, subtract the powers. Next one, 6 goes into 24, 4 times. Subtract the powers. 4 minus what? Invisible 1 is 3. Good. Plus 6 goes into 30, 5 times. The x's just cancel away, huh? There we go. How we doing? Questions on that? No questions? That good? So these are easy. This is easier maybe than the last section, huh? When you said lead us through another one like it. This will be like it. This will do that same kind of weird thing. So let's try this one. So 18x to the 6th minus 45x to the 4th plus 81x. All right, make that 3 separate fractions, right? Three separate fractions. Okay, so 3 separate fractions. 3 separate fractions. Now, we divide the numbers in the front and we subtract the powers. So 9 goes into 18 2 times.
Yes, sir.
And then subtract the 6 minus 2. 4 minus. Good so far? 9 goes into 45. 5 times. Subtract the powers. 4 minus 2. 2. Now, for the last one, here's where the trick comes. Yeah, 9 into 81, 9 times. The bigger number was on the top, but when it comes to the powers, invisible 1 on the top, right? 2 minus 1, where's the bigger power? Bottom. So the x ends up x to the 1, or just regular x, on the bottom. That's what happened in that other one. Does that make sense? Everybody see what's going on there?
When you're doing it day to day, you probably just, you wouldn't split them up into 3 fractions because you just remember to divide into each one. But if it was a monomial on top, you would do the canceling if they were
Right.
the same. Does that make sense?
Yeah, so you could just leave it as one big fraction and cancel, 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 except not on this one. Because on this one, one of them ends up with a separate denominator, so you would have to separate this one.
Okay.
Yeah, so it's when there's extra left on the bottom for anybody, you gotta separate them. is on
Does
that, yeah.
that line go all the way across, or is the X just part of the 9?
Yeah, no, just good question. Just right here, why? Because he came just from these two. Just the right side. Yeah, so that bar, that fraction bar, is just for the X, right? The other guys, the middle and the left, they had nothing left over on the bottom, huh? So we can't let this X become everybody's denominator, because that's not true. The other ones had no denominator left over. Yeah, good question, good clarification. Everybody seeing that? Because I remember, you're right, glad Melody brought that up, because I remember I've seen a lot on the exam, people go like that, or they have one of those options. They'll have that as one of the multiple choice options. Those publishers, they know what you're going to do to make those tests up. So watch out. That bar only is under the right term there, the right fraction. Is that good? These rules all making sense?
It wouldn't be like 9 and 1 over x? Or is that makes it a different problem?
9. So do you mean like 9?
And then 1 over x next to it.
Oh, gotcha. 9 and then 1 over x like that. That's okay. That's the same thing.
Oh,
Yeah, that's another way to say the same thing. Why? How do I know? Yeah, good question. How do we know what Maikisha's saying is the same thing? Why is this the same as this?
Because it's multiplying the one.
Yeah, right. Because anything alone, this 9 alone, meaning not part of a fraction, really is in the, to be alone is to be in the top. 9 times 1, 9. Same thing. So that's why. So always know anything alone that's like on its own is the same as being in the top. To be alone is to be in the what? Because it's over 1. So it's really in the top. So it's the same either way. Anytime you have anything in the top, you could just put it in the front. It's the same thing.
okay, that's how I wrote it at first.
Yeah,
Will
that's.
MathXL let us plug it in like that?
I believe so. I believe so. I'm not sure. But it is mathematically the same. All right, good. Okay, so 24 s to the 9th p to the 10 minus 30 s to the 7th p to the 8th plus 48 s to the 3rd p to the 4th all over 6 s to the 3rd p, right? All right. There it is. There's a big one. So make it 3 separate fractions. Three separate fractions. Then divide the numbers, subtract the powers. So 3 separate fractions like so.
A little tough with my answer.
It's a little messy, isn't it? So now we need to divide the numbers in the front, subtract the powers. So here we go. So 6 into 24 4 times. subtract 9 minus 3, I'm going to put it over here, or maybe right here, 4s to the 6th, and subtract the p powers, 10 minus 1, divisible 1, p to the 9th. Good for that one? Is that making sense? Divide the numbers, subtract the powers. Minus. Is that good? All right, so now 6 into 30, 5 times. Subtract the power, 7 minus 3. Oops, there's my 5 looking like an S already. Try to make that a little more clear. So S to the 4th, and P, subtract the powers, there's a visible 1 on the bottom. P to the 7th. Good.
Yes.
One more, plus, I'm moving over here, plus 6 into 48, 8 times. Subtract, oh, the S to the 3rd just drop out, huh? Gone completely, no S. Sometimes, here's a common mistake I see over the years. Student will go, oh, no, I know they cancel, so I just put S with no power. No, no, no. If you write nothing on it, because I know they're thinking nothing, but if you write S with nothing, what's invisibly there? A 1, and that's not right. 3 minus 3 is not 1. No, so we can't put any S at all. And then the P's, 4 minus 1, 3rd power. There it is.
So if it happens to be 6s to 4, and then the result will be under 4,
A regular, an S. We'll do
Yes.
that. S to the
On-
1st. Oh, if it was on the bottom. If there's a
Yes.
4 on the bottom, yeah, there'd be an on the bottom. Yeah, wherever the bigger is. Yeah. That's right. Yeah,
I have a
Joel.
question. Now, the exponents, you move it to whatever denominator and numerator, everyone's bigger.
Whichever is bigger.
You don't do that with the numbers, though. Because the negative 30, you divided the 6 into it, or the 5 into it, so it just became a negative 5. So I wouldn't put the negative 5 in,
Oh, okay. I hear what you're saying. Let me address two questions with that.
yeah,
So, as far as if you have a negative power, those jump to the bottom, and but negative like base numbers like negative 5 doesn't jump to the bottom. That's true. You're right.
and then I'm asking, but because at 30, because it was, the 5 was bigger than 30, the answer wouldn't go to the denominator spot?
Well, what we're comparing, remember, is the original two numbers, the 6 and the 30, not the answer.
Yeah, exactly.
So whichever of those is bigger, that part's still true. Whichever of those is bigger, who's bigger, 30 or 6?
Well,
30.
yeah,
So the answer ends up at the top.
even though it's a negative 30?
That negative, remember, isn't necessarily on the top or the bottom. It's just in the front.
All right.
Yeah. That's just in the front. So he's not in either one of these, really. Yeah. And even if he was on this guy, I mean bigger, like bigger number. Like
All right.
30 is still a bigger number, positive or negative. Yeah, that's irrelevant of sign. Yeah, good question on that, Joel. Yeah, negative, positive, I only really care about that with powers.
All right.
With numbers in the front, doesn't matter, doesn't affect the rules at all. Only with negatives in the powers do we do the up and down rule.
All right.
Yeah, good clarification. Is that good? All these rules, so many rules, huh? All right. Okay, so we've got 3m to the 8th, whoops, minus 9m to the 6th, plus 24m squared over minus 3m to the 5th. All right, try that one. Break that into 3 separate fractions. Okay, good so far. So break them into three separate fractions, and the signs on the top end up between. Right? This minus sign ends up there. This plus sign ends up there. But the negative on the bottom is on the bottom of all three now. Good, okay. Let's talk about the signs for just a minute. What have we learned about signs? Remember what I told you about a fraction? A negative sign on a fraction, that's the same as the negative in the top only or in the bottom only. Right? Not both, though. Why would it not be both negative top and negative bottom? Because that'd be positive. Two negatives is positive. That can't be the same. So negative in the front is negative in the top only. Or, if you prefer, negative in the bottom only, but not both, right? Because both would be two negatives, that would be positive. So, when it comes to a fraction then, to really simplify it, when it comes to a fraction, all you care about is how many negatives. One negative, it's negative. Wherever that thing is. Top, bottom, front, whatever, it's all the same. You know, one negative in a fraction, it's a negative fraction. Doesn't matter where it's at. Well, look right here. This fraction, how many negatives we got? One. The front of the middle fraction, 2. These guys are both on the middle fraction, aren't they? Right? They're both in front. That's their baby, right? And whatever's in front of them, that belongs to them. So there's 2 minuses in front of that middle fraction. Positive in the middle, huh? Doesn't matter where they're at, bottom, front, top, whatever. 2 of them, they get together, positive. And the third fraction, 1 plus 1 minus, negative. Makes sense on the signs. So the middle fraction really has 2 minus signs on it, doesn't it? The one that came from the original subtraction and the negative in the denominator. 2 negatives. All right. So let's do this thing then. So divide the numbers in the front. So 3 divided by 3, it's gone. M8, subtract the powers, m to the third, but it will be minus because we already agreed the first fraction's negative. The middle one, positive. 3 goes into 9 3 times. Subtract the powers, m to the 1, or just m, if you want. And the third one, it's going to be negative, because positive over negative is negative. 3 into 24, 8. Subtract the power. Now, where's the bigger power? Bottom. M to the third on the bottom when I go 5 minus 2. And that bar must stay only right there, like Melody was pointing out. It can't go all the way across. It's just on that third fraction, huh? Jose?
So the m to the third, the one stay negative?
This one?
Yes.
No. Remember, we look at wherever the bigger one is.
No,
Yes.
since it's already negative from the beginning.
Right here?
Yeah, from minus 3m over 5.
Oh yeah, so this is negative. Yeah, this negative went to here.
Okay.
Not the power, though. That's a different world, right? Is that what you're asking? What is it you're asking?
No, the base, m. I thought it would stay negative.
Okay. Yeah, let me write this a little cleaner, and I think I can show it better. So 8 over m, what was it, third? So are you asking, Jose, is this m negative?
Yes.
Yeah, now when you say negative, do you mean should there be a negative in the front here?
Yes.
Or do you mean should there be a negative in the power?
No, in front of m.
Okay, a negative on a fraction is in the front. Remember what I was saying up here?
Okay.
Negative in the front is the same as negative in the bottom.
Yes.
It's all the same. So yes, it doesn't matter where that negative is. It's there. It's there. I just brought it from the bottom and put it out here in the middle, but you can leave it there if you wanted. If you really wanted, you could actually write this plus a negative. That's the same thing.
Yes.
It doesn't matter where the negative is. Top, bottom, front, it's all the same thing. And that, you know where that's really important is on the test next Wednesday. I mean, obviously everything's important on the test, but I mean, in particular, multiple choice, they might have it looking a little different. You don't want to be too quick to grab that none of the above, right? You want to know, oh, I have it this way, and they just put the minus in the front. I remember that's the same thing. On a fraction, 1 minus, bottom, top, front, it's all the same. Alex?
Is it satisfactory to leave m to the third as a fraction there? Would you want to further try and simplify and multiply m to the third to bring it out of a fraction?
No, we can't.
Because then you'd have to do it with everything else.
Good question. You're only allowed to multiply by m to the third or anything other. We'll get into that probably just next week, maybe the week after. It's never long here in the summer. We'll get into all the fractions and multiply, but let me just, since you're thinking of that, let me just mention this right now. It's a good thought. Let me mention, you're only allowed to multiply or do whatever things, fraction things, if you do both sides of an equal sign. We don't have an equation here. Or top and bottom of, you gotta do it with balance. So you gotta do it both, and there's two ways to balance. Left and right of an equal sign, we don't have, this is not an equation. Or top and bottom of a fraction. So if you did m to the third, you'd have to do top and bottom. We don't want to do that. We don't want to mess with that. So no, it must stay just like this. Yes, all right. Guys are becoming. All right, so 20 x to the 9th minus 20 x to the 5th. Plus 15x to the 4th over 5x to the 5th. All right, try that one. Separate those into three fractions. So make those three fractions. So separate it into three fractions. Good so far. Now we divide the numbers in the front, subtract the powers. You changed the numbers back there, Jose?
No, good?
Yeah, okay.
Yes, okay.
All right. 20 over 5, 4 x to the 4th. Bigger numbers on the top there, right? So everything's on the top. Good. Minus 5 goes into 20 4 times, 4. And what happens with the x's? Just totally cancels. No x at all. We can't write an x because that would be x to the 1, and that's not right. No x at all. Huh? In the middle, fully canceled. Plus 5 into 15, 3. Now, what happens with the x's? X to the 1 or just regular x on the bottom. Because the bigger power, the 5, was on the bottom, huh? And we can't let that bar go all the way across. It's just right there. On the. Getting more comfortable with that. Had that three times now, I think. We've had everything 3 times, haven't we? Good. And then you'll do it one more time in your homework, right? You'll be a master of this. Then we'll do it on the practice exam. That's the plan. Again and again and again and again to where we get the real exam, you're like, I've got this now. That's the hope. This section's easier than the first one we did today was the hardest, huh? The negative powers and, oh, you mean this whole chapter compared to the first exam? This material might be easier material. Maybe. Maybe.
Separate out everything.
Right.
Either way, we're ruining trees.
That's right.
That's why you
That's
buy a
right.
whiteboard for your house.
You could do a whiteboard at home. That's true. Some ways it's nice to have notes to look back to, though, when you get to the test or the final.
Can't you use like a pane of glass with dry erase? Window pane?
I have no idea. All right, now they're giving us the same thing with words. Now, are you tracking with those words? Yes, sum. What does sum mean? Add. So they want me to add this and divide it by that. So in other words, it's 6y to the 7th minus 3y to the 5th plus y to the 4th added to 6y to the 7th minus 3y to the 5th plus 3y to the 4th divided by, all of it divided by 2y to the 4th. See what they're saying there?
Yeah, we can,
Not scaring me.
All right. It might be easiest to add them on the top first. First, you can add like terms on the top, right? First, add the like terms on the top before you start dividing anything. It'll save you a little bit of work. Because you can combine things on the top. That way you won't have to double your efforts. I don't think anything cancels.
Yep, there's one. 6y7.
No.
No,
oh, those
No,
are like
the-
terms of one.
Oh, that's right.
Make 12y to the 7th.
They're both
Yeah.
negative.
All right. This is his baby here. He's a plus. And over here, here's his baby, plus.
Oh.
This minus
Yeah,
belongs to
yeah.
the 3y. Remember, whose baby's who? Whose? All right, there's signs in front of them. There's signs in front of them.
You can add them though.
Yeah, you can add them. You get 12y to the 7th. Yeah, and we don't mess with powers, right? It doesn't make y to the 14th, does it? We don't mess with powers because we're adding. Remember, when you're adding, you gotta keep all those rules separate, huh? You're adding, you just add numbers in the front. You don't mess with powers, right? We only mess with powers for multiplying and dividing. All right, is everyone going okay? So we combine 6y to the 7th and 6y to the 7th. It's 12y to the 7th. And minus 3y to the 5th minus 3y to the 5th is minus 6y to the 5th. And y to the 4th and 3y to the 4th. Understood 1 there. 4y to the 4th.
That's as far as I know.
Is that good so far? Over. And now you need to make it 3 separate fractions, huh? 2y to the 4th, 2y to the 4th, 2y to the 4th. Like that. So far, so good. So I combined like terms on the top. Right? 6y to the 7th, 6y to the 7th made 12. Minus 3 and minus 3 made minus 6y to the 5th. And the 1y to the 4th and the 3y to the 4th. Everybody okay? You remember that invisible 1 in front of the y to the 4th there? Okay. Now we have to subtract these powers. This is y to the 4th. Okay, so divide the number 6, subtract the power. 7 minus 4 is 3. Like that. And minus. Divide 2 goes into 6 3 times. Subtract the powers. 5 minus 4 is y to the 1, or just y. Good there. And 2 goes into 4 2 times. And the y's completely cancel. There it is.
Oh, that big long polynomial is just for that.
Yes, just for that. Does that make sense? We have done them all. We need to end with our clicker quiz, but is that good? Questions on that last one? So we covered all those sections. 2.6, 2.7, 2.8. In case you were wondering what else you could do for your Memorial Day weekend, there's some math. All that will be due on Tuesday. Like that. All right. And then we'll wrap up with our clicker quiz here. What number are we going to do? Why don't we do our number... I'm going to make it a little bigger. There we go. There we go. Let me put on the clicker. The clicker's not on yet. So, can you see that? You guys want it bigger? It's on the screen. It doesn't really fit the screen anymore.
Those are exponents, right?
Yeah, those are, yeah, it doesn't, the program doesn't put the powers very high, does it? Yeah. Those are exponents. I'll make it a little bigger. Whoops, I'm too big again. All right, I have to fill them in. There we go. So there it is. That, yeah, those are powers. Yeah, exactly. Those are exponents. Those are powers. It's t to the minus 3 over t to the minus 6 power. That's right. That is a power.